Okay, alright guys, in this video we will quickly go and understand the working of Git. And so this can be a little lengthy video. You can also log into GitHub. I think I'll show you the GitHub integration also. Just in case you have not logged in, please create a GitHub account. Just log in, verify your email and other things. Be in your GitHub account. Keeping it a little lengthy here, so because we can understand the flow of everything in this video. So first of all, okay, let's understand how the Git works. Okay, so we already discussed like Git is mostly a stupid version control system or content tracker. It is ideally a content tracker. So the architecture, let's understand the architecture of Git. So how Git architecture, okay, how is the data it tracks? So pretty simple thing. At a high level you can think like Git as a dictionary. Excuse me. A dictionary, if you remember, we have discussed on dictionaries or map. So a map is a key value pair, so it stores a key and a value. So Git has Git basically is a persistent map. Some people call it as a persistent map. Persistent means it can store into the disk. It's a key value pair, persistent key value pair. So what does it actually mean is, suppose you have a file. Okay, so we'll see this in action. Suppose you have a file, let's call it as abc.txt, another file pqr.txt. So but the content is the same. Let's say the content is hello. So what does Git will do is, Git will take the content sequence of bytes and associate a hash, specifically known as SHA-1. It creates a SHA-1 hash. So the SHA-1 is going to generate you a 41 digit hexadecimal. So you can think like it's a unique key. So now when new content comes in, okay, if it sees, okay, it's just for optimization, if this content is there, then it will use the same content. In case my content was different, I'll say hello 2. It just creates another hash, because every character changes the hash. Okay, if the content is different, currently we'll look at the case where content are different. Okay, so then later we'll see if the content is the same, what happens. It creates another hash. So every content is actually stored in Git as an object, and Git calls it as a binary large object or blob. A blob. As of now, just a high level. So you can think like so the contents are kind of values, or you can think that it's a blob. It stores the blobs as, and the key as a hash, SHA-1 hash. Another blob, okay, so, and a SHA-1, another blob and a SHA-1. Okay, so basically not only blobs, so you will come to know other objects. There are other objects which commit tree. Okay, likewise, so we'll come to that, all these things in detail later on. Currently think that Git is going to store a lot the content as a hash. That's the whole thing you'll have to understand. So given a content, okay, some content is given, so it generates a key out of that content. That's simple as that. So Git generates a key out of the content, and the key algorithm it uses is a SHA-1 hash. So SHA-1 or SHA-1 it uses. So this is generating the key. So this blobs and their associated keys are going to be stored internally, okay, within your repository. So you have, when you create a repository, we discuss a repository okay, before. So the project which you create has to be within a repository. So repository is a persistent store. So within the repository, a lot of blobs you can currently think like lot of blobs are stored, or binary large objects are stored, and each blob will have a key associated with this. And Git internally is nothing but a key value store. It stores everything as a key and a value. Now going further, to understand the architecture, so how we can work with Git, so you should understand mainly 4 areas of Git. There are 4 areas, okay, in Git. Okay, so what are the main fundamental areas is so first area, it has a stash area. So stash, I think we will go to stash later on. So the main 3 areas we will discuss. Okay, so the 3 main areas of Git. So one is the working directory. So working directory is a place where you're going to start adding your folders and files. Your project folders and files will go inside the working directory. So once your some work is done, you'll have to put it into an index. Okay, our next phase is the staging area. The staging area is like the launch pad, okay, or this is the cache where you will put the file which is you already made. You have to first put it into the staging area. After putting the same file into the staging area, okay, so same hash, okay, so let's say a file is there and the file is modified. Now when you put it into the staging area, a hash is generated. Okay, let's say 8ABC or something like that, some hexadecimal hash. So but the third area, so the working area, the staging area is the launching pad, or you can call it as the next phase before committing. So it's a pre-commit area. And the last phase is, you know, repository. So repository is going to store all the commits that we discussed last video. So whatever in the staging area, so all has to be on the same version. Okay, so some file you generated a hash, but this hash is not in the stored in the repository. So once you stage it, you have an option to unstage it. Okay, you can bring back it from the staging area. So let's say 3 files you have. So you decide which files to commit. So you can stage every file. Okay, whatever the content you have, you bring it to the staging area. And then might be if you don't want this to be, you know, committed, so you can unstage this. So this staging area is going to be now only one file too. So you can move from your staging area back to your working directory. Okay, so the staging area is there where you want to stage the value. So or the index, it is also known as an index. So the staging area will generate a hash. Okay, and this hash which is generated now, a SHA-1 hash, okay, it's a blob. It creates a blob here. The blob is generated here. Now the blob has to be permanently part of a commit. We need to do a commit operation. The last part is from the staging area we will have to commit it. So once you commit it, it goes into your repository. Until and unless you don't commit, it is still in the staging area. So you can like play around with the staging area. Okay, you can remove it, unstage it, you can do whatever you want. So once then you are already very sure that okay, so this has to be now going into the repository. So this is the staging area. So these are the 3 main areas. Okay, once you start doing, you will understand it. So so from a working area, if you want to do put it into a staging area, you will use a command known as git add. Git add whatever the file was, let's say file1.txt. Once it is added, now we can unstage, we can commit. So if you commit it, it goes into your repository. Okay, so what happens when you do commit, all these things we will discuss in detail now. When you do a commit, you will use a command git commit. Okay, and you'll have to put a message why did you commit, because the SHA-1 hash which you're going to generate depends upon the message, the author. Okay, all these details it will take, and then it will generate a SHA-1 hash. So it is necessary to put a message. So why did you commit? Let's say this is my file1, okay, initial change. So it takes all these values, so the message which is generated, who as the committer. So let's say there are two people working in the team, so then I committed, okay, on the changes, okay, and the the real file was initially committed by another person, okay, and so now I am making another commit on it. So might be the person, the first person has did a commit, and now I am another person who doing a commit on as file, the same file. So who the author and who is the committer and all that things, it will take all that details, and then only it will generate a hash. So commit does generate a different hash, and it will also generate a particular hash. So the blob is there, so the blob comes into your committed area, okay, and it will also generate a particular object known as a commit object, okay, and the commit will be pointing to that blob, okay. So so I can know that this commit is containing that blob, okay. So these things might be initially a little not very much clear initially, but when you practically do it, you will understand. So if you go to the Git SCM website, okay, and you will be able to see that, okay, they have kept a visual cheat sheet. You can see that cheat sheet, okay, visual Git cheat sheet. If you go to the docs, so in fact they have like 5 areas. So we will go to the upstream. Upstream is like a remote, okay, so GitHub, okay, something. So I'll cut this off now. I'll cut the stash also. Stash where you will store the work in progress if you have something in progress. So this is also currently not required because we are just starting things. So stashing not needed as of now. So you have a working area. So this workspace is your working area or working directory. Index is the place where you are. You can see that what is an index, they have written it. Files you want to commit before you commit. So this is a pre-commit area. Check in, so you'll have to check in the files. You need to first add them to the index, also called the current directory cache, okay. Staging area, caching area, stage file, or something like that you can call it. So this is kind of a before you launching it into the repository, you keep things play around in the index, then later you can remove if you want, if you don't want it. So stage the data, okay, and then finally you can commit it. So the repository is the place where you commit all files changed since you the last commit except untracked files, okay, in the index. So everything which is marked in the index will be put it into your local repository. Just have a look around on this visual cheat sheet. You can see a lot of things here, and so this two places we currently, the stash and the upstream, we will revisit it later on. So these are different areas. So currently if you want to work, okay, on Git, so we have to first I think we will see in an action, so you'll understand. So we will create a project folder, and might be we can add some files into the project, and finally we can stage it into the staging area. From staging area the files go into a repository. So might be we can unstage some files, okay, and then might be you are finalized, okay, what things to commit. So the staging area can be considered as a place where you want to kind of a launch pad where you first figure out like what things I need, then finally you can commit. So let's do this so practically, so you'll understand it. So I'll show you. For that, first you need to have Git. I'm making a repository with the name repo1, so you can follow along with this video, so you can share your integration with me. So once you install Git, you may get something called the Git bash. So you can open the Git bash inside here, and the first command you can learn is git status. So git status, and git status says that this is not a repository. So first we need to do is and we need a repository here. So let's call it as git init. So git init will create a repository. So always use the visual cheat sheet. You can see the visual cheat sheet to understand. They might be giving some thing here, okay. Workspace, you have some commands, okay, so you can just see this. I'm not going through that, okay. So you can say git init, okay, and once you initialize it, you see you get a .git folder. Make sure your and your hidden files are visible. So if you have hidden items, you may not get anything here. Okay, so make sure your hidden items are visible. Once your hidden items are visible, so you can see there is a .git folder. So the .git folder is actually an internal repository folder, so it is an internal folder, so we should not touch that folder. But I think we will touch the folder to understand how Git works. Okay, so if you see, there is a master coming and additional stuff here. So what is a master? Okay, so if you see, there is a head there, description, configuration and all that things. So first I'll go to the head. If I go to the head, you can see the head is pointing to the master, ref head master. So what is ref head master? See, refs is a folder, heads is there, and so there are no masters. So as of now, our repository is empty, it doesn't have much of the things. So what are the objects in Git? So there are no objects as such. So I told you the objects are blobs and trees and commits. So these are plain objects. So I think this is completely empty. So as of now, I'll go to the config. Any configurations are there, so we'll just see that. Repository, no much things here. So first of all, I think you should set up your editor to edit the things. So I am setting up my editor. So I've just kept the command here for the editor. So to set the editor, you can use git config -- global. Okay, and so the global configuration you can use git config in your, so I have already set it, but still I will put it. So in my so you usually, when you have a fresh installation, you just can try that. So I am setting up Visual Studio Code as the editor. So whenever I want to edit the configuration, it is going to generate this. And also I will say I want to open the global configuration, git config -- global, and I'll open the editor. So just, if you see, my configuration file will get open. I told you, when you commit something in Git, you need a username. It needs the user is the author and the committer basically, and it needs the email ID who has committed the changes, because in a team there might be 10 people. So how do I know who has made the change? So this is so important in Git to set the username and email. Okay, so either you can open the Git and just add this the way I have specified. So this maps to my GitHub account. Okay, so if you see, my GitHub account was having the same user. So this, my user is the same, Kanan-Subhav, and my email ID is the same I've registered. In case if you don't have it right now, you can just make sure you add this node here. Okay, so you can add this attribute user and name. Okay, and so I think that is fine. So once you add that configurations, okay, so and the editor is done and the configurations are set. Once you add, then I think you are almost ready to go. So repository is there, and Git already knows who is the person who commits. So he knows the author, okay, of the files and other things. So first of all, what I want is, I want to keep track of files, right? So let me create a file. I'll use echo command in Linux. So I'll echo into echo hello world, or hello into a file. Let's call it as file1.txt. So you can see that it just generated me one file, and so this file has the content hello. Now what, with this file is actually where it is, in which architecture, where is it? It is in the working directory, staging area, or in the repository. What do you think? So you can see the status. So do a git status, and so it has I think git status will give you on branch master. So this master which you see is a branch. We'll come to branch later, so I think I'll keep a separate video for that. The master branch is there, but just it's empty branch. Okay, so the branch has no commits. So untracked file, so this file is never looked at by Git. Git does not track this file. Anything in red means git status. I think there is a short status -s question mark. So staging area, okay, so there is nothing in the staging area. So this is not moved into the staging area, so that's why you're getting a red here. So, and if it is not in the index or staging area, so the index, staging area, all are the same. Okay, the index or the staging area, if you see guys, okay, so if you are not in the index, so then you know, it is untracked. So before you commit it, we have to stage this. So this is kind of a launch pad, okay, launching pad before or pre-commit area, or it's a cache. So we have to cache it first before you do the commit. So now when you are caching it, what was the command we said? So we see that it's in red sign, but now I'll do a git add to that file. So when I add, very important guys, there is inside the objects folder, okay, you see the change happening. So pretty much pay attention to that. Okay, so well, nice. Now I say git add the file, I'll say file1.txt excuse me. So when you add it, you see the guys, so there is a new folder created. The folder is containing the folder contains the SHA-1 hash. Okay, so the whole SHA-1 hash, if I copy this, control C, I cannot change it. If I change it, it's mess up. Okay guys, so it's the key which was generated. I told you the whole git is a kind of a repo, key value pair. So it created me a key with the SHA-1 hash, so with the data which I had in the file. So what is the length of this file? Like, just excuse, the length of the hash, you can just, I am using JavaScript here, the console of my browser, so I think CE. So you can see that I'm putting CE space and I paste the file name, and all together I'll find the length. So you can see guys, it's a 41 digits hexadecimal. So the SHA-1 is generating a 41 digit including the folder name. So there is a command. So these things you don't have to know the details, but I'm just showing you. Okay, so there is a command, I think git cat file minus print me the details of the hash. So I put the first 4 character CE01. okay, so it will print me the content of that that hash. Oh, what does that mean? It means see, this is a dictionary, and think that the dictionary had a key like 5055. Now what I'm telling is, okay, give me the content of 5055. So what is the content of the 5055? That value it should stores me. Okay, great. Now if I say, okay, what is the type of that? Is the content kind of a blob? See, it says it's a blob. So we discussed git has so many blobs. Okay, it can have commits, it can have trees. So we'll come to that trees and commits in a minute. So ideally it created you a blob. Oh, I said git add, so it generated me a blob. Okay, and what is the status now then? Anyways, git status. Now you see that it says changes to be committed, so that means it has to now do commit operation, and from red you can see it has gone to green. Pretty much good. So green means you are in indexed or you are in the cached area. So or staging area, you can always do unstaging operation. You feel that, okay, might be I don't want it or something like that, you feel something. So some of the files you don't want to commit, so might be put it in the staging area. Make sure which are the files which you are having. Currently we are only doing one thing. Might be when you do the project you will have a better understanding. When you do a little more complicated things, you'll understand it. So you will see a lot of green files. So when you see a lot of green files, when you do git status, oh, you see that, okay, that file I don't want to commit ideally. So then you can unstage using git rm remove minus minus cached and the file name, so it will go unstaged. Okay, so it will be moved from the cached. So you have the index. Okay, you have, so we I think we familiarized with the index. We are familiarized with the workspace or your working directory. From working directory we move to the index. From index we can move back to the working directory. If you want, you can try out all that things. Now the next thing is, when we move to index, we could also find that some blobs were generated by git. Now the last part is the local repository, so we'll have to put this into the local repository. So to put this into the local repository, so pay attention carefully. The objects folder is going to, now you're going to have a a lot of things will come when you do a commit, so we'll have to analyze what exactly a commit is. Okay, so I'm clearing the screen. I'll do a git commit, and I told you when you do a commit operation, the hash, so commit does generate a hash, so everything is a key value in git. I told you everything is a key value in git, so obviously commit also should generate a key value, and in fact it generates a key value. It needs a commit message, and the commit message does is a part of generating the hash. So git commit -m, I will say this is my file one. Okay, so do I want to commit this? Well, fine, so let's commit the file one. Okay, file one change. Okay, or should I have to add one more file and do it? What do you think? Okay, well, I'll add one more file. Okay, so I'll say echo hello world into file2.txt. so I'm adding one more file. Let's see the staging area. You can see one is in your staging area, another in your working directory. This is untracked. So what do you think I should do now? So I didn't commit anything, right? So I'll say okay, fine, I'll add the file2 into the index or the cache or the staging area. I'll added it. Now guys, see this, there will be one more change happening. So you see guys, so there is a time bound 2:42 is the time. So the file is generated. So you can quickly see what kind of file is it. A blob generated. So let's see that. Git cat file and print me -p to print the details. So what is the hash? 31E0. so everybody will get the same. So if you are working on your Windows machine, you are using the same file content, exactly the same content. If you type in your machine, you exactly going to get the same thing. Okay guys, so make sure you type the words properly. If you have typographical errors, it will generate a different hash. So everybody should get 31E0. so, and you should see the content is the same, and the key has a value. Okay, and the value is hello world, and the type is a blob. So blobs it is storing. And again I do a git status minus shorthand syntax. You can see all are added into the A is added in staging area. So or git status, so you can see that everything is added into the staging area, but no commit has happened yet. Now you see carefully guys, so now I have two blobs. Now you're going to see the magic of commit. Now when I do a git commit, I'm going to put the message. So file 1 and file 2 changes update change initial change. Okay, initial change. So when you do a commit, oops, you see that there are two files created. What is the time? 44. At time 14:44 there are two files created. You see that? So definitely they are hashes. So git is going to store everything as a hash. So every key is a hash. So every data is the value is some kind of data. Now what are the things generated? So now pay attention carefully guys. So if you closely see this, git has created me a commit, and the master branch, will come to branch later. It created 9588C. so that means basically this could be mostly a commit operation. So let me see what is this using cat file. How can I check it? Cat file. So the key is okay, I'll print the key contents. What is the key name? 958C. okay, so there you go. So I am just the author and the committer. So author is the person who added the file, and committer is the person who made the changes. So if I share it with another collaborator, author would be Kanan, and the committer would be some other person if other person makes a change. So committer is a person may change. So if you see the whole the tree, so it actually, if you see the commit type, so it's going to show me something more. So it shows me there is a tree, there is an author, there is a committer. Okay, and all these things are actually taken care of while you committing it. And commit actually created me an extra object. So obviously a commit, one entry into the dictionary got created, one key was generated, and the value is this. but there is one more value inside the tree. So that means I think mostly I got one more object created. So that is A523. So if you see A523 is there. So let's do a cat file on that. So let's understand what is that cat file A523, and I will print the contents of that. So see guys, it is pointing to the blob. Okay, so this is pretty interesting. So it's pointing to the blobs. So if I kind of draw it visually, you'll understand. A commit is created. Commit 1, let's call it commit 1. Commit 1 actually points to a tree. Okay, so commit 1 points to a tree, and the tree contains. Okay, so what is the commit name, by the way? Commit is okay, so this is my commit, and it created me a tree. The tree is nothing but the folder. Okay, and the folder, the root folder, the folder had two files, file 1 and file 2. So you guys can see this, file 1 and file 2. So this tree contains file 1, and file 2. File 1 content and file 2's content. If they have the same content, then they will have the same hash. So you will not create one more hash. So you can see the hashes are different. CE01 for the first file, 31E. Zero for the second file. So this is the whole tree, and the tree does have a hash. What is the hash of the tree? Tree is A523. Okay, and remember, so there is something known as a master, and if you go inside Git, you can see there is ref. So there is something on the head. Okay, so head points to what? Head points to the master, and the master is inside ref head master. So let's go to ref heads master. Now you see guys, this was empty initially. Now you see it is pointing to a commit 958C. What is 958C? 958C is a commit. So your head points to the master, and the master is pointing to 985C. So this is a pointer master. And your head is a pointer to a pointer. So why do you need a head and all? We'll discuss later on. Head points to the master. So this is your object structure. So every commit is handling a tree, and the tree is available. So I would like everybody to try this much, and take a screenshot of all the work you did. I will try to keep it short, otherwise it may be lengthy. So implement the first simple commit with 2 files. Okay, and you can also add one more file and see if I do one more commit, what happens. Okay, so you have to draw the structure, you try that out. When you do one more commit, I'm not showing this, this is a task which you have to do. When you do one more commit, the second commit, when you when you print the second commit, it will have. So if you see, if I am having first commit, it contains the tree, the author and all that things. The second commit will have additional pointer. It will contain definitely it will have a tree. Okay, the folder where it is. If you're adding files, it will just have that files, other details. Also, the head and the master will now move ahead. Okay, so the head and master is now going to point. The master will point to the latest commit, or now the head is going to point to, just like a linked list, the last commit will be C2. Okay, just add another file and do a commit, file 3, and do a commit, and just show me the tree. So what does the tree contain? Does it contain a file 3 or not? Try that out from your side and then share it across with me. Excuse me, I'll end the first video here.